Very good morning to all of you. On behalf of Sri Ishwar College of Engineering, I welcome all the participants to this program. This is webinar number 12. The topic is Rehabilitation Robots. To present on this topic, we have an excellent academician, Dr. Santhakumar Mohan from IIT Palkad. He's an youngster, but already we have seen his presentation. So wonderful. He's a dedicated research person. This robot topic is highly inspiring to every one of us. Ever since the first robot was demonstrated in the year 1950s, all branches of engineering, all domains started concentrating on robots. In fact, the meaning of robot, it is a slave. It's a slave laborer. So you should keep the images you have seen in the movies far away from the topic. Robot is a slave. It is supposed to obey whatever you say. And especially after this COVID-19 problem, people again started talking about robots. Robots serving the corona patients, robots employed in hospitals. What is this kind of robots? This kind of robots is something like a rehabilitation robots. In the sense where human beings are endangered. You cannot go and work in a place. In those places, you can think of using a robots. It is a replacement for human being, already replaced in all industries, most of the humans, where the industrial operations are being done by the workers. So to talk on this topic, an excellent person has come, Dr. Santhakumar Mohan, on behalf of Sri Ishwar College of Engineering and on behalf of all the participants, I welcome Dr. Santhakumar Mohan to this program. To introduce him formally to the audience, the participants, I welcome Dr. Michael Roch Kingston. He is an associate professor in ECE department, Sri Ishwar College of Engineering. Dr. Michael, you can take over.
Okay, sir. So, good morning, everyone. I'm happy to welcome the speaker at this point of time, Dr. Santhakumar Mohan from IIT Palakkad. So, basically, to introduce about the sir, Santhakumar Mohan sir got his PhD from the specialization of robotics and control from the Indian Institute of Technology, Madras in 2010. From June 2010 to March 2011, he has worked as an assistant professor in the Department of Mechanical Engineering at National Institute of Technology, Calicut, Kerala. Then he worked as a world-class university postdoctoral fellow at the Korean Advanced Institute of Science and Technology, Daejeon, Republic of Korea. In addition to this, he received another prestigious Brain Korea 21 postdoctoral fellowship, the same institute from the year 2011 to 2012. In the year 2012, he joined the Faculty of Mechanical Engineering at the Indian Institute of Technology, Indore. He is holding the visiting faculty positions at IIC Bangalore, Indian, then RWTH in Germany, ECN, France. His research area actively include underwater vehicle and underwater manipulator design and control, parallel robotic platforms, assistive robots, field and service robot. Finally, he has received an Outstanding Young Scientist Award for the year 2014 from the Korean Robotics Society European Masters on Advanced Robotics Plus Fellowship in 2018 and 19, and Alexander von Humboldt Fellowship in the year 2016 to 17. Sir has published more than 100 articles in various referred journals and conference proceedings. On behalf of Sri Ishwar College of Engineering, we are happy to welcome Sir to deliver the guest lecture. Sir, you can deliver the lecture, sir.
Dr. Santhakumar, you can take over. Dr. Santhakumar. Mr. Basha.
I think he is not available. We're checking. Michael sir, can you call him, sir?
Uh, dear audience, Dr. Santhakumar will come back very shortly. He will come online. I'm sure all of you have got a great interest in robots. In fact, my subject also, a favorite subject is robots. I am basically a mechanical engineer, and I used to wonder how mechanical engineer can teach robots to students. And when I went back to the textbooks, I understood ever since the computers were invented somewhere in 1940s, people started working on computer in all branches, including mechanical engineering. So this is a offshoot, this is a byproduct of development of computers. And in fact, the most important, the role played by robots is mechanical companies. I think Dr. Santhakumar has come online. Dr. Santhakumar has come online. Yeah, you can take over, Dr. Santhakumar.
I think now I am online.
And you are
But
online.
when
You
I
are
got a
online.
phone
Don't
call,
worry.
it was
Don't worry.
disconnected. Can
You
I
can
start
go
the
to the
session?
first. You can go to the first slide and then start talking. Now it is yours. Welcome. Welcome.
I think still.
Dr. Santhakumar, you can start. You are able to hear me?
Yes, yes, yes. I'm
You can start. You can start.
okay. Okay. Then I'll just go back to. Very good morning, one and all. I think there was a small technical delay. Please excuse for that. And today the topic would be recent trend in rehabilitation robots. In specific, I would be sharing my experience in rehabilitation robots to you. In that, I would be sharing what are the challenges and how the current aspect which is coming up in rehabilitation robot. That's the overall idea. So now, before going to the topic, let me give a motivation to this topic. Probably you all must aware that the current we call Indian population, there are more young generation, right? You call young generation Y or X, whatever you call. So now we are proudly saying that we have large number of young population. But imagine after 10 or 15 years, so we would be having a middle or probably elderly age people. But as per the current scenario, our you call social life has been changed. For example, when I was grow as a kid to a teenager, I used to get my family members are actually like around 10 to 12 members, which was a joint family. Now my son is actually like getting a family where me, my wife, and you call sibling. This is what family. Even within our own community, you can see that the husband and wife would be away. They used to meet once in a month or something. Now imagine 10 or 15 years or even 20 years later. The scenario definitely going to change. So even that time, actually, they would be meeting once in a while. But you can see that the elderly people or middle-aged people would require more resistant or accommodating person. So this is one big issue. And second thing is, if you go to a Western country, in specific Europe, you can see every street you can feel or you can find a rehabilitation center in specifically physiotherapists. But in India, it is not so like that. I think. Hello.
Slide is not visible, sir.
Slide sharing. Santhakumar,
Sharing has been disconnected, sir.
Which one?
The sharing
I'll
is
just add
disconnected,
it
sir.
once.
It's
Yeah.
fine.
I'll just make it.
Share, sir.
I'll just make it. I don't know why. I think.
Now it's okay.
So you are able to see it?
Yes. Now it's okay.
I'm using. Yeah. So that is one big issue. Second issue is actually like we don't have proper physiotherapists, expert physiotherapists for this big population. And third thing is, even we have physiotherapists like what we used to call, for example, when there is a chaos or probably crisis in engineering, we used to start more engineering college. Now that is overloaded, but imagine we can start more engineering college and we can generate more engineers. The same scenario can brought for physiotherapists. We can start more BPT, MPT programs, and we can actually like train them and we can make it. But that is not going to solve the issue, because so every therapist supposed to do a physical task that is really a laborious work. And second thing is, even the expert requires some additional aid. So in that sense, you can see that the rehabilitation is not only like rehabilitating the human being, but that supposed to actually like move on in the second or probably third stage of the development. So in that sense, you can see that the mechanism or probably a mechanized system obviously will help. Even this is was there even in probably 15 years back. But what right now the scenario has changed because of the advanced computing facility and as well as advanced electronics and electrical accessories. Even the mechanism or mechanical design also improved. So in that sense, what we can actually like find, so we can simplify the work of the physiotherapist, and we can make sure that the physiotherapy would be available more time than the, you can say, a smaller narrow gap. So in that sense, if we bother, we can actually like definitely see that the rehabilitation is upcoming. But before going to the rehabilitation, I just come back one important aspect, because this particular slide set would be consist of several videos, images, even some kind of you call data which is come from my own article, and sometime it would come from the outside article. I cannot actually put it. Yes?
Sorry, again, the screen share.
Connection, sir.
I think I have, I don't know, like why.
So once again, you disconnected the connected, sir. There's a network issue.
Sir. Network problem, sir.
I think I'm getting full signal, right? I don't know.
Sharing is not working, probably.
I'll just
Sharing.
disconnect. Okay, then I don't know. Like
Sharing.
yesterday itself, we would have tried this. Okay, I'll just go back.
It's okay, sir. You can share, sir.
It keeps going out.
That's what I think probably.
No problem. You can. Basha, any other command is there, or simply share? That's all.
Simply share, sir. Simply share, sir.
Yeah, but for
no, now I'll just check whether if I
okay.
move the slide, whether again it is going out.
Yeah. Now visible. Now it is
Still
visible.
there is no slide.
Yeah.
Okay. So this particular slide set, which consists of several resource media. So obviously, you please aware that this is only for educational purpose. That's why I'm not citing each and every figure on the bottom. It would be given at the end as a reference. So I would not be referring every figure or slide at the bottom. Okay. So now I will come to the broad theme of robotics. The theme of robotics actually like moved in two major things. One is related to human being, the other related to the economic benefit we call industrialization. So for example, the first one, if you recall, like one of the dog, which is actually like very good companion for any you call human being. So this is what really a good thing. But in future, that cannot be possible in all the cases. For example, some apartment, they will not allow a pet to have or probably some places we cannot actually like have it all the time. So that time we can think about some kind of companion robot. So if that is the case, you can see that one broad theme will be actually like human friendly companion robot. The other side where you would be talking about more you call advanced robot, we call autonomous mobile robot, which consists of manipulator. It can do a several tasks. It can do assembly, it can do all operation which is related to the industry. For example, here I put a figure where you can see the manipulator arm is inspecting a power plant, and if any operation need to be done, it will do automatically. For example, it is testing the you call the pressure and all the you can say supply, whether the you call gate valve all actually like in a proper position, whether the pressure is attained. So now it need to actually like energize the system. So you can see that it is automatically going and it is actually trying to energize by pushing the core into the case. So these are the cases. So now you can see that there are two broad themes. One is which is centered to the human being, the other one is centered to the industry. So unfortunately, this particular topic, we are bothering about the human-friendly robot. In specifically, we'll be talking about assistive. Even in that narrow down, we'll be talking about rehabilitation robot. But the other case, which is industrial aspect, where smart industrial robot, which we simply call autonomous robot. So these are the two broad themes, and this particular session we would be focusing on the human-friendly robot. So now you can see that the slide itself says that. So one of the humanoid robot is trying to actually like helping you can say elderly person, and as well as it is going to give a company. That's what. So we are trying to do. So but if you talk this in a broad sense, so we will come back where the rehabilitation comes into a place. So when we talk about rehabilitation, the rehabilitation is actually like two kind of you can say broad classification. One is actually like in order to enhance your probably human body or anatomy or neuron, so you can actually like do some kind of therapy, or the other side you can actually like assist in terms of probably your physical enhancement or social enhancement. So in that sense, the rehabilitation is need not to be a only therapeutical robot, even it can be a assistive robot. For example, wearable exoskeleton can actually enhance the physical interaction to the environment. Or probably you can see about some kind of humanoid robot which is interacting with the human being. For example, you go to a museum, there would be a one mobile robot which would be having a screen and a smiley face, and it will come to you and ask what can I can do for you. Then if you say something I need to go here, then it would give you the map and other things. These all actually like come under assistive robot. But this particular talk, what we are focusing is more on therapeutical robot, where the therapy also like two kind of therapy. One is actually like just to give a emotional. For example, an elderly person is actually like really feeling sick just because so nobody around him or around her. So but if you actually like giving some kind of emotional, for example, when the human being is smiling, the robot also like smile, or it is doing some spooky or probably some kind of naughty things. So then the emotional will actually like get motivated. So this emotional can be virtual reality or just a small set of you can say robot which can actually like induce this kind of you call emotional. So this is actually like one broad theme which is actually like again come under therapeutical robot, but what we are focusing is actually like more on physical therapy. So when we talk about physical therapy, obviously we are talking about human being. So the human anatomy will come. So then you can see that the physical therapy can be given to the entire body. Then it is full extremity. But what usually we used to classify the physical therapy robot into two major. One is would be upper body. The other one is lower body. So the upper body usually like try to enhance the neuron, or you can say neurorehabilitation, in order to get, for example, the stroke affected patient or paralysis patient to enhance their body to recover their pattern. So for example, they will actually like play a game, or they will actually like draw paint, or just to enhance their body in such a way that so they can actually like regain their you call neuron. That's what the whole idea. The other side is actually like lower extremity, mainly for regaining their gait and regaining their actually like walking pattern, so that they can actually like stand by themselves and they can actually like go further. So in that sense, you can see that the physical therapy also like broad, and full extremity usually people call the complete exoskeleton, and upper exoskeleton and lower exoskeleton will come. But The physical therapeutical robot need not to be all the time exoskeleton. That's what I mean to say here. So now in that sense, I just want to give a small idea how the you call cumulative annual growth rate increasing day by day for the, you can say, rehabilitation or assistive technology. So when you see it is actually like increased 12.5 percentage of overall cumulative annual growth rate of the economy. For example, if you talk about North America, you can see almost it is like 50%. You talk about Europe, it is more than 30%. So Asia Pacific, where we are actually like living in specifically, this Asia Pacific come under Korea, Japan, there actually like more concentrated research has been done and enhancement has been done. So only the place where the low you can say impact, which is actually like Latin America and Middle East and Africa. But overall, if you see that the rehabilitation and assistive technology is growing, in that you can see the rehabilitation robot is actually like as almost equal to the assistive robot, the overall share. So when we talk about this rehabilitation and assistive technology, usually we classify it into four major things. One is actually like robotic rehabilitation system. So for example, I put a one small picture where the exoskeleton is attached with the human arm, and there would be an interactive screen, and the lady who's sitting, she would be doing the, you can say, task which is associated with the computer based. So now her actually like body will actually like do the task with the aid of this rehabilitation system. Then the regaining of his neuron or probably the strength would accompany. The second thing which is we usually talk is assistive robot. So here assistive robotics in sense, it can be any kind of assistive, which I put one of the figure where, for example, one of the lower limb impaired guy who's actually like need wheelchair, but when he is sitting in a wheelchair, he need to mobilize himself. On top of that, he has to manipulate himself. So when he is operating, he cannot actually like manipulate all the time because his probably one arm might be paralyzed. So when you can actually like use one arm for operating, and as well as you can use another arm, which is the mechanism arm, or you can say mechanized arm, which can actually like enhance the body. So this is one kind of assistive. The third thing is which we call assistive technology, which is intelligent prosthesis. For example, bionic arm or probably expanded soft based you can say prosthetics, or you can actually like say that it is actually like just artificial leg kind of thing. So this is another thing where people are actually like doing lots of research and keep on actually like coming. This rehabilitation robot also would help in developing these prosthetics. That's what we mean to say here. And the fourth one is actually like nowadays actually like the experienced teachers is actually like very less. Not in India, but in I can say abroad in specifically European countries. So they are actually enhancing some kind of actually like robots for the school education, and as well as, for example, the pedo clinics and all. So where it would actually like energize the kids, so that actually the kids would be feeling a lively environment. So this is what the you can say broad picture. So now we will actually like go to a very specific. You can see that the based on the part of body and based on the purpose of use, you can actually like classify the developed system. So far you can actually like divide into several things, but you can see one thing in the part of body where we call upper extremity and the lower extremity is actually like more concentration happened, which are what I highlighted here are actually like the commercial or research product which was successful. And you can see that the other side, which is actually like activity which is on the daily life assist. So even here you can see that one of the popular, which is what we call exoskeleton. In that one of the popular exoskeleton we call smart mobile walker. So these are actually like some kind of you call classification. So now when we talk about this, so one can actually like see so what this particular topic is going to talk. So obviously I need to give that address. So when we are talking about this topic, I already said I would be sharing my own experience in rehabilitation robot. So for that, I will be starting the rehabilitation robot in terms of therapeutical robot here. So the therapeutic robot, I can say it can be used for upper limb or lower limb, but this particular talk would be more focused on lower limb. Even in the lower limb, it can be come under two things. One is the body would be completely hanged on the, you can say, frame, and the body would be actually like enhanced with the body.
Dr. Mohan, audio, look for audio.
Sir, audio is not working, sir.
Audio. PowerPoint is visible. PowerPoint is okay. Only your audio.
Sir, you can reconnect, sir.
Sir, you can reconnect, sir.
Reconnect means he has to go out and come inside.
Yes, sir.
Or on the top, that reconnect button will come.
It won't come.
Dr. Santhakumar, audio is not visible. Audio, I mean audio, not able to hear the audio. He has to go out of webinar and come inside Basha, or what is the idea?
And come again, sir.
Hello?
Yeah, okay.
Give panic button, sir. So panic button means we all of us will be reconnected, sir. Sir, if he goes back and come back again, it will be no problem.
Some other audio is visible. Anybody else connected through the same one, Basha, or only we three are there? Okay. I think let Santhakumar come back. Probably audience should keep thinking on this topic, and those students who are working on projects, one of the most interesting topic is robot. Basically, when we talk about robots, one important parameter is the number of dimensions and also number of axes. When we say axis, it is the number of possible movements of a robot. Normally, for all industrial robots, we give maximum 5 movements only. That is enough to replicate an industrial worker. For example, a person working on welding machine, working on assembly, working on painting, just 5 movements is enough. It is in fact an imitation of a hand, human hand. When we look at the hand, all of you can try your hand now. It's 5 axes. One is the shoulder here, shoulder movement, and this movement, and the wrist movement, and the finger movements. So 5 movements is all required for an industrial robot. I think Dr. Santhakumar is again back on the screen. Dr. Santhakumar, you are on the screen. Dr. Santhakumar. Okay, I think he's about to join. He had some technical problem. He will be joining shortly. So if you look at automobile companies, the best automobile companies in India, most of the operations are done by robots only, but it is called industrial robots. Industrial robots complexity is not very high. Whereas, for example, the topic today, the rehabilitation robots, or the entertainment robots. Today you have entertainment robots which can play music, which can do dancing, and it can do various activities like human being. It has got minimum of 20 plus movements. For example, you require a head movement, eye movement, and various other body motions. Normally, human body, probably after this program, you can try up to 25 movements are possible. Up to 25 movements you can, for example, if you go with a leg, you have the knee, you have the joints, and then you have the fingers and the leg also. So like this, if you count, minimum 25 movements are required for a robot to work, a humanoid robot to work. Probably the most fascinating robot is the humanoid robot. It exactly looks like a human. And in fact, Saudi Arabia, they gave citizenship to a robot. They have recognized a robot like a human being. So probably in future, robots will replace human beings in as many places as possible. Not only in entertainment industry, almost in all areas. And with invention of the artificial intelligence, robots can think and they can take decisions like human being. The current area where people are focusing is artificial intelligence, and you know that. And this area is going to be the next few area. Dr. Santhakumar, you are okay? You have come online now.
Can you hear me now?
Yes,
sir.
you continue. You continue. I was just talking to the participants.
Really
You can
sorry,
continue.
I don't know like what happened in the middle.
No
Because-
problem. No problem.
Yeah. So
You
this
can
is
start
the-
from the slide.
Yeah,
Yes.
this is the slide where I left. Can you see the slide set? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Okay, I will continue. So if you see the body weight support system, there are actually like three things. One is on a treadmill, the other one is just a foot plate operating system. The third one is an overground. But these all require some kind of assistance because the body is supposed to support or enhance so that you can do it. So this is actually like second stage. The early stage where the people in a bedridden, so they need assistance in certain way. So the stationary trainer is the more focused in the entry stage. So I just want to show what kind of, you can say, problem the physiotherapists used to get it. For example, treating this lady for a lower limb, this particular guy has to actually like lift the leg and has to do several kind of therapy in several rotations or several repetitions, which all actually like take you call laborious work. For example, one physiotherapy is taking a 50 patient in a day. Definitely his body or his you call his supporting system will not support. So for example, in order to enhance this, people has come up with a robotic based system. For example, what this guy exactly tried to do it, the same thing is this particular robot, which is Kuka robot is doing it. So this is what we call actually like stationary trainer in specifically the bedridden patient. But the other side, what I mean to say as a ground based, or you call the system which is actually like for gait training. For example, you can see the manual training required at least 2 or 3 assistants to do the treadmill gait training. Right now, she is actually like hanging on the overweight, and actually like we see that these two people are actually like trying to push her leg on the treadmill, and this lady is actually like supporting. Now you can see that at least 3 people required to do this particular task. So now the same thing you can see in a robotic system. So initially you do a trial and then you can see that the treadmill operation is very much simple, right? So this is what the main advantage. You can see that the laborious and actually like huge work was actually like simplified and actually like made it. So this is what the current state, and we are actually like seeing what really the challenges and other things. So when we talk about lower limb rehabilitation robot, so we will be focusing on the lower limb. The lower limb would be having set of you call motions. So obviously lower limb also like will be having a 7 degrees of freedom, where 3 would be on the hip and 1 would be on knee and 3 again would be on the ankle. So it's a 7 degrees of freedom. But when we do the physiotherapy on the leg, so we usually focus 6 kind of therapeutical treatment. In that, the 4 are major. Which are the major? One is actually the hip adduction and abduction, which is on the hip rotation on the you call lateral plane, and the remaining three all in a sagittal plane, which is you call longitudinal plane, where the hip would be actually like extend and flexion, and the knee would be extend and flexion, and the ankle would be extend and flexion. So these are the actual like four important therapeutical treatment which we used to do it in the lower limb. So apart from that, there are actually like three other which I mentioned earlier. There are seven. So one is actually like internal and external rotation of the hip, where we would be keeping in this particular pose, and we would be rotating this knee lateral plane. So for example, in this case, you would be actually like keeping your thigh and along with the hip joint as one particular location, and then you would be actually like rotating your hip in lateral plane. So indirectly you would be keeping your shank or crush or we call calf muscle, and then you will be like bending in left and right. So this is really advanced therapy which is not really required at the initial stage. That's why I did not put that figure. Similarly, the ankle also would be having an ankle abduction adduction, and ankle would be having little more therapeutical treatment. These are not really actually like laborious and as well as complex. So that's why I did not put it here. So now when we see these all, so what would be, as a mechanical point of view, what would be the real task or the challenges? The challenge is actually like you need to provide the range of motion which need to be fulfill all kind of therapeutical motion. So this supposed to be a active or passive. The initial stage we call passive. So what do you mean by passive here? The patient will not do any kind of assistance. The patient would be idle, and we would be actually like with a mechanized system, we will be giving the motion. That's what we call passive motion. So when we call active, then the patient also started giving some kind of you call motion primitives. That's what we call active. But right now, the first primos is the passive range of motion. All possible motion supposed to be provided. The second thing is, so individual leg would vary based on actually like its heredity and as well as physics structure. So obviously, when we talk about the supporting system which we call orthosis, which is very close to a exoskeleton, where you can see that the hip and lower part all would be supported as three joints with three bodies. So that is what we call orthosis, which is very similar to exoskeleton. But in rehabilitation scenario, we call orthosis. So the orthosis is supposed to be adjustable, and as well as your hip joint and the ankle joint need to be properly adjustable in terms of overall picture. And the third thing is we are thinking about the rehabilitation system in a robotic sense. So obviously the payload need to be vary, because you can see the teenage weight would be different and the elderly age would be different, and you can say the fat and the thin guy would have different payloads. So obviously the system supposed to accommodate all kind of payloads, and on top of that it's supposed to provide a high precise you call motion primitives. So apart from that, the system supposed to be the system supposed to be stable, and as well as you call provide the safety aspect. Apart from that, you can see that the actuator should not put it on the orthosis, which will give a bulky, and as well as the patients would get actually like fear to enter into the system. So these are the major things. Apart from that, there are actually like assistive things, which is actually like when we talk about any system, we think about energy and cost supposed to be very low. And when we talk about safety aspect, the system supposed to be self-locked system, and the system supposed to be modular. For example, now I am doing in a left leg, the system can be easily accommodated for the right leg, like kind of modular system. And when we do, for example, upward downward exercise, even if I do for a gait to, you can say, sitting position, it need to be adapted. So apart from that, as I already mentioned, the passive is the prime most, but later on you can bring the active. So when we come as active, there could be two cases. One is completely active, where the patients would do all the things. The other one is assistive. Whenever the patient is required, you would give the assistive system. So obviously your controls are supposed to give passive range of motion, active range of motion, and active assistive motion. And on top of that, you might have done exercise in the gym or probably in your home. Some of the exercise you will not do really probably bending under things. You would be just stretching, right? Indirectly, you would be giving a resistance to certain things. So, for example, when the you can say patient is doing, you would be applying some resistance or you can say load. So against that, this guy has to actually keep the hand or keep the leg or keep the body. So these all actually we call isotonic treatments. These all need to be calm. So on top of that, one important thing is we need to actually take the feedback from the orthosis so that you can actually enhance as a closed loop system. So when we extend these things, so we'll first focus on the, you can say, three motion on the sagittal plane, where these three motion. So these three motion is actually very simple. So the hip, knee, ankle rotation along with the, you call lateral axis, indirectly the motion would take place in the longitudinal or sagittal plane. So now this can be achieved in several things. One simple thing is you can just connect motor individually to individual joint. So that is we call actually active orthosis. So that is not really required or that is not really encouraged by the patients, because I also did a survey in Switzerland, one of the commercial product when we launched. The patients really actually not ready to see if the system is bulky and the actuator is actually attached to the orthosis. They are not really ready to come up. So obviously we will think about the method too, where indirectly controlling these joints. For example, now I put a ankle point along with that one, you can say, manipulator. I can actually drag this. That's what the idea. Now when we are doing that, there are several combinations will come. So there are several configurations are possible. You have to see which is best and how that can be. So in that direction, you can see that there are several, you can say, attempts made. I put some of them, not all of them, some of them. In that, the motion maker is one of the commercial product which was actually very popular in European community. In fact, this is actually come out of one of the university, which is we call EPFL, so which is in Lausanne. So they initially come up with this as a R&D product. Later on, SwartTech is the company which has actually commercialized as a motion maker. So now this is the product which is actually I already said, it is active orthosis, where you can see the actuator is actually connected with the orthosis itself. The orthosis in the sense the supporting system. So the other one is actually you can see that it is the Japanese base, so which is actually TEM we call. So this is actually you can see that the leg is actually attached with the supporting system, but the manipulator is a serial manipulator that would be making the motion of this particular thing. So similar to this and similar to this, actually combine and come up with the iLeg, which is one of the Chinese made. And this robot we have seen already, it is a KUKA robot, which has actually enhanced. This is actually normal KUKA robot, which is added one of the part that would be attached. So this is a simple, you call 6 degrees of freedom manipulator, but you have an end effector that would be actually enhance this particular therapeutical motion. So apart from that, these all are actually serial connection, but people tried with parallel connection. So there are several attempts. Even this is ANKUR is one of our attempts, and HipBot and physiotherapy are actually some of the successful model. And one of the cable driven which come from the, you call Asian Institute of Science and Technology, which is in, you call Asia. This particular thing is cable driven. These are all actually some of the attempts. But still the, you call the fulfillment is not yet done as compared to the Gait training, which is actually a treadmill trainer. There are several commercial products have come, but when we talk about stationary trainer, very few attempts made. Even then there are only 2 or 3 commercial products have come. Even they are actually not in use a broad spectrum. In that sense, you can see that there are actually a requirement to develop a rehabilitation robot. When you are actually establishing or developing a rehabilitation robot, there are several tasks associated. One of the tasks is very primos. You have to observe the, you can say, therapeutical motion when the therapist is performing. So this is actually one broad, you can say, task, but this task can be enhanced with one orthosis, which is not supposed to be powered orthosis, but we can actually try to simplify the therapeutical work by the physiotherapist. On top of that, we can use as the motion capturing device rather than going with the motion capturing device for 22 lakhs or probably 1 crore worth. You can just make a probably statically balanced orthosis, then you can do it. For that, I will come back later on, but you can actually do the therapeutical motion during the, you can say, the therapist who is doing the motion. Or that's what I mentioned. We can actually come up with the statically balanced passive orthosis. I'll come back this very detail in the later on. And the third thing is actually like once you think about the, you can say passive orthosis system, then you have to come back with operating the passive orthosis with some kind of mechanism system, or you can say mechanical system. So this is what we call foot plate based rehabilitation mechanism, where the foot plate would be attached with one another manipulator. That manipulator would be energized. Just to give an idea, so for example, you can see that if I put a passive orthosis and I attach with this manipulator, what you can see that this particular manipulator would give the all record motion. For example, the stem and all. So this kind of idea which we need to think. Then we have to definitely come up with the passive range of therapeutical motion when it is a bedridden, and as well as later on it's supposed to be a gait training. And we need to come up with a health and recovery monitoring system. Then we have to think about when the passive range and the health recovery is coming up, then we have to adapt the active assistive, then finally you have to adapt the active therapies. Then one optional which we can come up, for example, one guy is actually like due to some accident he lost his one leg, but his second leg is active, so we can put that leg into this particular setup and we can actually like capture all motions, and based on that you can actually like come back with a limb parameter and you can duplicate the, you can say artificial leg that can be useful for the system identification as the case, which would definitely helpful. And the final one is which is actually like smart system, which is smart means simply cloud. So you have a huge data that you put it in a cloud, that's what you call smart. So when you have connected the health and recovery monitoring system into the cloud, then it can be used as a teleoperation monitoring and control, where the physiotherapy can be done in home and the physiotherapist can see from their own clinic and they can suggest what to be done. So that is what we call smart system, that also can be as an optional. So but these all actually like come as a major task, but one can actually like come up with a research methodology. So this is what we actually like exercise when we develop our own system. So first we have to think about the recognition of the, you can say need. Definitely the need of lower limb rehabilitation is required. So we are going next stage. So we are actually like conceptualize the solution. So we are coming up with the several configurations and we are seeing which is possible. The first important thing we have to see the passive orthosis with gravity balance. So once this is done, then we can actually see that how to energize this passive orthosis. So for that we have to do a workspace analysis and we have to come up with the final, you can say dimension. Based on that you can identify best possible manipulator, and then you can actually like make the dynamic model and do the simulation study. Motion dynamics you go ahead, then structural dynamics you come back as a design study. You see the design is actually like providing all required motion and all required strength. Then you make a prototype along with the passive orthosis and you do the test. So for doing the test, the robot is not only a mechanical system, it is involved the control aspect. So you start with the controller. So you propose some motion controller and the stability analysis you do and perform several robustness study, and then you enhance that with the real-time prototype and do the clinical gait data. So this is the research methodology we supposed to adapt. So in that direction, if any improvements you can redesign at any stage. But when we talk about the first stage, we talk about the you call static balance system. So I put two things here just to induce your attention. You all notice that you can say mini drafter is actually like by default engineering product, right? So any engineer who do engineering at least for first year, he has to carry the draft. So one can say why the drafter is having two parallelogram mechanisms. It is supposed to be 3 degrees of freedom as a serial connection, but why it is supposed to have parallelogram mechanism? So it is very simple, right? Because this particular point is actually like if I have a single rod and another rod, then this particular point would actually like endure with, you can say, angular rotation because of 1 and 2. But when we use a parallelogram mechanism, the orientation at the end point will not get changed. So this is one advantage, right? So this we need to use it for our mechanism. Then the second thing you might have noticed the table lamp. The table lamp, when you drag anywhere within the table, within the proximity or the stretch, so it won't actually like fall, it would stay back. Even you extend completely or you fold completely, it would stay. But why or how? So one, you can actually like clearly focus. You would have seen that there are two springs, and some cases parallelogram mechanism would be there. Some case it is just a string. So you can see that this spring is actually like trying to, you can say, overcome the gravity, which is actually like induced from the part of this. So this is what we call the gravity balance. Now the spring is actually like having a stiffness. The stiffness is actually like enduring some kind of restoring forces. The restoring forces would be having two component. One component always actually like make the potential energy constant. That is what we are actually like trying to use it. If one can actually like recall Lagrangian Euler formulation, so there is an energy difference, then the motion exists. So now here as a static body, the energy is only a potential energy. If you keep the potential energy constant, there would not be any motion. These are the basic idea. The idea can be enhanced. Now you can see that the lower limb would be coming with a parallelogram mechanism and the helical spring. Now you can see that the system would be statically balanced. In fact, we have come up with a very fine design, but since it is patent, it is actually like submitted a patent, and as well as we contacted some industry, so we cannot show the real design to outside people. That's why I just give a skeleton. So you can see that the thigh is attached with one parallelogram mechanism, and the crest or shank is attached with another parallelogram mechanism. This parallelogram mechanism is attached with a spring. Whenever you pull or drag this rotation, the spring will energize, and actually like it would give the required force to make the static balance. Now the system can be used for a initial therapy. Now the physiotherapy lift, he would not be feeling the weight of the body because the weight is already compensated. You would actually like simply apply the physiotherapeutical motion. That motion would be captured by these three encoders, and then we can actually like move ahead with the you call end effector based rehabilitation system. So when we talk about the end effector based proposed system, you can see that the patient would be outside and the supervisor would be outside. So he would be actually like monitoring and doing it. So before going to that, the first stage, the initial measurement and the treatment by the physiotherapy, the patient took it to the physiotherapy, and the physiotherapy will do all kind of therapeutical motion. That motion would be captured, and the recommended therapeutical input would be captured, and that would be interfaced with the desktop computer. And the motion would be captured, and based on that, the motion planning would be generated, and the motion control scheme would be, you can say, established. Now the supervisor would just, you can say, attach with the device to the patient, and it started. You can actually like see that the motion would be start functioning. Now at any point of them, the patient or the supervisor feel that it is going wrong or it is actually like hurting the patient, they can apply the emergency stop. It would stop at the safe position. So this is what the overall system. Now what we are focusing on this proposed system as the mechanized or mechanical system. And then would be actually like 0 degree, which is the completely stretched, and then completely extended is minus 150, and the hip would be plus 122 minus 30. These are the suggested therapeutical motion. So based on that, you can come back with the least possible leg and the highest, or you can say tallest leg, and then you can find some kind of workspace. So based on that, you can actually take the compromised workspace for your system development. So now the system development is done. On top of that, when you talk about the physiotherapy, so there is one particular treatment we call continuous passive motion. We simply call CPM. The CPM would be having only one actuator. It doesn't actually like make several aspects. So it would be attached with the leg. The leg would be completely stretched and fold in a continuous manner. When you energize the system will go to and fro. So based on that, this two, you can say, joints would be actually like completely fold and stretch. So this is what we call CPM, or continuous passive motion. When somebody is actually like developing a system, this also supposed to be inbuilt system. So if all these kind of aspects if we consider, we can actually like come back with several configuration. But accidentally we come up with one configuration. I again say accidentally, because I was not working probably 7 years before. I was not working in medical assistive system. I was working in parallel robot. So one of the outcome of one new family of parallel robot when I was presenting in IISc Bangalore, one of the senior professors said that why can't you actually like develop a lower limb rehabilitation based on this? So based on that, this is the platform which we come up as a new family, but later on this particular you call parallel manipulator used for the gait training. This is what the system, and you can see the adjustable seat with the passive orthosis has come. So now this is what I mean to say that parallel manipulator. So this parallel manipulator will have X, Y, and theta rotation. So that can be used for, so ankle point, you can say X, Y translation and ankle point rotation. That's what we are actually like coming up. So this is what the scaled prototype which we made it in-house at IIT Indore. Then actually like we have come up with several mathematical background, and then we have verified with virtual prototype, and then prototype I'll just come back to the experiment. So this is the experimental setup. We energize with a very simple microcontroller just to test it. So we have used a simple Arduino. Later on we have used DSpace system just to enhance the system further, and we have come up with the experimental result says that the required clinical trial was done with a simple teenage patient. So unfortunately, that video was not with me in this particular laptop. I just show the motion which is generated by the system. And this is the system which was the proposed one in Conceptual, later on which was actually like modified. And since it is actually like working with the ball screw joint, so it doesn't require really the static balance system because these are actually like statically balanced. So that's why we did not show that into the picture. So apart from that, we have come up with several other attempts. So one of the attempts which are actually like popular, which is we call Ankur-1. So Ankur means a baby plant. So this can be used as the sit and stand both cases. So it can be used for, you can say simply stationary trainer. Later on, it can be elevated and it can be used for gait training. And this is mainly for all kind of therapeutical treatment. So in fact, this is actually like one of the Russian collaborated project with my group. So these are actually like our simple attempts. And when we talk about the key technologies, our current issues, there are four major issues which we need to address. One is the safety, because although we have come up with all safety norms, still the patients, you can say they are not well aware, or they are actually like really scared. You have to ensure that the safety is high most, and it is actually like at least 4 or 5 times better than the manual system. And the user interface supposed to be very user friendly, and it is supposed to give very much awareness, and it has to enhance the virtual reality so that the patient can be feel it as home or as it outdoor. So apart from that, when we talk about this safety and user interface, usually the system would be very much expensive. For example, the SWAT tech system, which would be actually like come probably like as similar to your surgical robot, which is very expensive. So definitely one cannot afford. So then we have to see that how to make a low cost and how to make easy maintenance or less maintenance. So on top of that, you all know like ethical aspect or safety aspect additional. So you need to come up with a very strong ethical aspect in such a way that all the data would be actually like secured, and as well as you call any controversial comes that would be addressed here. Okay. So with that, you can see that the development is actually like coming from the market creation. So we are still in the basic research in terms of stationary trainer, but that need to be enhanced as a transnational research for rehabilitation robot. So that would be as a pilot program. If we take, then we do a clinical research along with the physiotherapist, then we can think about market. Probably in 10 to 15 years, you can see that several, you can say commercial products will come, but India is lagging in that. I hope only probably 4 or 5 labs are working in rehabilitation robots in a broad spectrum. So one in IIT Madras, one in IIT Bombay, one in IIT Kanpur, and one in IIT Kharagpur. Even IISc, they are not predominantly working. This is what I come across. So with that, I'm actually like ending my thing with my lab aspect. So I'm actually like not only working in rehabilitation robot, I used to work in several domains. So my lab is actually like safe, we call, so which come around all broad spectrum, where service to entertainment, that's what we call safe. So service assistive field and entertainment robots. So sometimes entertainment would be little odd, so we brought exploration as the cases. So these are some of our, you can say, successful enhancement. And with that, I'm actually like open to the moderator to.
Okay, thank you very much, Dr. Santhakumar Mohan. Extraordinary presentation. We
Was
appreciate
the one of
you
the
appreciate your research work, and I think it has got a big social angle also. Apart from the research on robotics, it has got a big social angle. You are doing a great service to the society. Now I invite Dr. Michael to go ahead with the questions. Michael,
Yes, sir.
yeah, you
So
can.
thank you very much. Okay, thank you very much for the session, sir. It was very informative and useful insights are given based on the robotics area, sir. So a few questions were posted by the audience. I wish to post it to you, sir.
Before that, I just ask sorry for everyone because somehow my internet or something was happened, the technical issue. I could not actually take up. In fact, because of that, the flow of the presentation also slightly scattered. I hope that did not deteriorate the entire overall picture. I hope I gave some kind of overview of rehabilitation robot. If somebody want to know more about the rehabilitation robot in Indian development or worldwide community, you can always write mail or you can actually like explore my webpage. Now I'm actually like ready to take up the questions if
Yes,
any.
sir. Sir, we are basically working on the area of robotics, sir. So for our design, we are using RGBD camera. So
Okay.
what? So to detect the posture of a person, sir. So since the viewing angle of the camera is narrow, it is found very difficult to measure the surroundings of the robot with a single device. Is there any remedy for this one, sir?
No, you can use simple, if it is indoor, you can use a Kinect sensor.
Okay, sir.
So
Kinect
which
sensor.
is, yeah, Kinect sensor, which is actually like enhanced with one additional where you can find the depth. So it is again RGB. Okay, the camera is RGB, which we call binocular camera, where there are two camera would be there, and there is one depth measurement with ultrasonic beams
Okay,
or
sir.
infrared beams based on what you are going to use. So we call Kinect.
Okay, sir.
If
So next question, sir. Touch sensing technology in the field of social robotics is having a good durability and has ability to recognize and localize touch gestures. But the spatial resolution is very poor, sir. And one more thing, drawback we observed is it is tend to provide a binary output, sir, which is just a signal whether it is in contact or not, which is quite limited for practical applications. Is there any way to improve this one, sir?
No, the tactile sensing, there are two cases. One is actually just a binary, we call proximity based. It will say that touched or not. But there are other tactile sensing where you can actually like find the load measurement. We call actually like strain gauge based or load gauge based, where
Yes,
you
sir.
can even estimate the force and then you can actually like manipulate. For example, you think about a you call gripper arm. So you can actually like estimate the force, how much energized or how much applied to the body. So there are several tactile sensing modes are there,
Okay.
along with load sensing.
Okay. So next question, sir. So recently we have explored the area of human graph position estimation, and we formulated an approach using linear regression based modified least LSM square, sir, least square algorithm to estimate the parameters, sir. So now, since the parameters should be remaining constant for a period of time, we found this method is a little bit coming short. Is there any other better way, sir?
Actually, like if you go with anything like LSM or simple regression, it is always a problematic because you need to train very hard. So probably you can enhance with the reinforcement learning along with regression because reinforcement also by default you call regression method. So there you will actually enhance the idea. So when you want sustainable data for a while, so this reinforcement learning method would actually like enhance the thing. So that way
Okay.
you can overcome.
Okay. Answer the questions. Thank
Okay.
you very much for the session, sir. It was very interactive, sir, and
Sure,
useful.
sure, sure.
Thank you, sir.
But really sorry, I don't know. Somehow it was actually like having a jerk or technical glitch.
Okay, sir. Okay, so no
Okay.
problem, sir. Thank
Yeah.
you.
Thank you so much.
Thank you.
Dr. Santhakumar,
Yes.
it was an extraordinary presentation. and the light disturbance is always part of any research work.
Yeah, that's
So
right.
don't be worried. I was looking at the chat box all the time,
Okay.
and everyone had appreciated. They did not mind the small technical disturbances. The content was so good because it's actually based on your research work. So what else they want? So it was an extraordinary presentation, and I'm sure you would have inspired and maybe motivated some of the audience, especially the students. They are so eager to do project work on robots. Dear students, Dr. Santhakumar is doing research work, and we have seen his presentation earlier also. He is so much into this robotics field. Probably you can visit his blogs and then the internet pages.
Just to add, so the two of the prototype which we made is actually like a BTech student's work. So the student joined as a BTP student, we call BTech project student. And in that, one student actually like continued as a PhD and he ended with a PhD degree.
Oh, great, great.
So the other student is actually like internship student who came from one of the Coimbatore based college, and he stayed only 2 months. And he made a proper prototype within the IIT Indoor House, and then we have come up with the 2 paper, and as well as the prototype also, you can say, supported. And in fact, when I was presented in EPFL in Switzerland, the company which was made the motion maker, they appreciated. In fact, they were actually ready to take the product once the commercial clinical trial is done.
Oh,
it's all student work, BTech students work.
Great, great, great. Probably one normal question is, whenever we come with robots, whether the jobs of human beings will go, especially the rehabilitation in this area like physiotherapy. Hundreds of our students, they are getting trained in physiotherapy, they learn physiotherapy. Maybe the robots, if they will replace them, will it not be an employment?
No. Actually, like that's
deprivation
why
for them.
No, usually these robots would enhance rather than replacing. Even this enhancement will create a huge job opportunity. For example, if I start a robotic company, I would actually like deploy or probably employ around 50 to 80 skilled laborers. So the skilled jobs will keep growing.
Definitely.
And on top of that, this robot required some kind of primitive assistance. So it won't actually like completely autonomous. So not like autonomous mobile robot, that is completely autonomous. But this is not completely autonomous. So you would be generating a system which would be actually like simplify the task of the physiotherapy. The physiotherapy is not at all replaced anytime. In fact, it is actually enhanced with the, you can say, mechanized system. In fact, I should say mechanized system rather than robot.
Thank you very much. With this, we are coming to the close of the program. Once again, I thank you on behalf of all the participants and on behalf of Sri Ishwar College of Engineering. And it is a great social service you have done and definitely inspired hundreds of our students. Maybe close to 1,500 were online when you were giving this presentation from various colleges in India. And this is a wonderful topic you have chosen. And thanks for participation on behalf of our college and on behalf of all the participants. I thank you again. Thank you very much, Mr. Mohan. Thank you.
Thank you, sir. Thank you. Thank you.
இங்கேதான் அன்பு கிடைத்தது, பண்பு கிடைத்தது, நட்பு கிடைத்தது, கனவு கிடைத்தது நம் ஈஸ்வர் கல்லூரி. இங்கேதான் தெளிவு கிடைத்தது, அறிவு கிடைத்தது, அறமும் கிடைத்தது, அனைத்தும் கிடைத்தது நம் ஈஸ்வர் கல்லூரி. பசுமை வண்ணம் கொண்ட சூழலிலே மயில்கள் கொண்ட எம் கல்லூரியே, ஒற்றுமைக்கும் தேசிய கொடியும் இங்கே நம் ஈஸ்வர் கல்லூரியே. அக்கறை கொண்ட நிர்வாகம் அது எங்கள் உத்வேகம், ஆசிரியர்கள் எல்லோரும் வெற்றிகளின் அஸ்திவாரம். ஆதவன் இல்லாமல் விடியல் ஏது, பாதைகள் இல்லாமல் பயணம் ஏது, கேள்விகள் இல்லாமல் கம்யூனிட்டி சென்டர், ஓப்பனர் தியேட்டர், அங்கே உலகம் கற்றுக்கொள்வோமே. நம் காலேஜின் பிளேஸ்மெண்ட் அது என்றும் சூப்பர், அங்கே வேலையும் பெற்றுக்கொள்வோமே. 4 ஆண்டுகளே என்றாலும் ஒரு குடும்பம் போல வாழ்ந்திடுவோம். 40 ஆண்டுகள் கடந்த பின்னும் நம் கல்லூரி நாட்களை போற்றிடுவோம். இந்த நிலையை நாங்கள் அடைந்தாலும் வாழ்வில் உயர பறந்தாலும் மறவோம் ஒரு நாளும் நாங்கள் ஈஸ்வரில் பயின்ற நாட்களை. ஈஸ்வர் கல்லூரி வாழ்க்கை கற்று தந்த பாடம், காலம் எல்லாம் கண்ணில் நிழலாடும். ஆதவன் இல்லாமல் விடியல்